Hello scholars, today we're going to be solving linear equations with one unknown. So we're going to be following the principle of isolating the variable, and by that I mean we want to get the variable by itself, preferably on the left, but if you can't work with it on the left, it's fine on the right. But we want it on the left because that's the preferred way of expressing what the variable is equal to in the end, right? So we do the opposite operation of what the original operation is. If we're adding, we subtract to get that number, to cancel that number from one side, and we have to do the same thing to both sides, so as not to really change the equation. We're just finding ways, convenient ways of isolating the variable. So here we have a positive 3. So in order to get rid of it from the left, we're going to subtract 3 to get rid of that. But we have to do the same thing on the right so as not to change the value of the equation. So when we take 3 from the right, we end up with x is equal to 9. Plugging back that answer into the equation, we can see that 3 plus 9 does give 12. So in algebra, whenever you solve for a variable, it's always a good idea to go back and plug that variable, substitute that variable into the equation to see if you get back your answer. So here we're subtracting 5. We want to isolate the y, so we're going to add 5, and these are known as additive inverses. The additive inverse of 5 is negative 5. The additive inverse of negative 6 is 6. When you combine them, you get 0. We have to do the same thing to this side, add 5, so we end up with y is equal to 33. And if we plug 33 back here, 33 take away 5 does give 28, so we know that we are correct. Here, 15 times what number gives 60? The inverse of multiplying by 15 is dividing by 15. So we're going to divide by 15 so that that becomes 1. And we don't want 0 in this case because the 0 would also get rid of the variable, right? 0 times the variable. So we want 1. In the case of multiplying and dividing, we want to have a coefficient of 1. So we divide by 15 and we have to do the same thing on this side. So x is equal to 4. And if we plug that back in, 15 times 4 does give 60. Or negative 10 times which number gives 75? So we're going to divide by negative 10 to get a coefficient of 1. And we have to divide by negative 10 here as well. So y is equal to negative 7.5. Negative 7.5. Now we have two operations going on here. We have a subtraction and we have a multiplication. So let's get rid of the negative 6 first by using the additive inverse, so that's 0. But we have to do the same thing on that side. So we have 5x is equal to 30. Now we divide by 5. So we can get our coefficient of 1, so we isolate the variable. And we also have to divide by 5 on this side. So we have x is equal to 6. 5 times 6 gives 30. 30 take away 6 gives 24. Plug your answer back in, substitute your answer for the variable, and check to see if you are correct. Alright, so two operations here. We're going to subtract 3 first from both sides. So we have 10y is equal to 70. And now we divide by 10 on both sides. So y is equal to 7. Here we need to combine our like terms, combine our x's, combine our whole numbers, right? So I'm just going to go ahead and do the necessary operations. I want to have a positive variable, right? If I make it so that the x comes on the left, it's going to end up being negative, which I want to avoid. So I'm going to take 1 from both sides. Alright, so I'll end up with 7 minus 2x equals 7x. And then I'm going to divide by negative 2x. Sorry, subtract 2x from both sides. So what we're left with is 7 is equal to 5x. So now we divide by 5. So we have 7 over 5 is equal to x. And we could always change that to a mixed number, or we can just leave it as it is, right? So x is equal to 7/5. So because I didn't want a negative number, if I had carried over the 7 over here, so I'd have negative 9. Negative 2x minus 7 would give negative 9. And then I would have 1 minus 8, which would give negative 7. Right, so I'll end up with a negative x term there. Alright, so let me just double check that I did the correct thing. So I took 1 from both sides. That cancels. 8 take away 1, that's 7. And then I'm dividing both sides. I'm subtracting. Oh, I should be adding 2x. Okay, so that's where I made the mistake. 2x. So this should be 9x. And then we divide by 9. Okay, so it's actually 7/9. Alright? So we took 1 from both sides. These cancel out. This gives 7. And now we have a minus 2x, so we want to get rid of the 2x. We do the additive inverse by adding 2x to both sides. So we have 7 is equal to 9x. And to get the x by itself, you divide by 9. So you do the same thing on that side. So the answer is 7/9. X is equal to 7/9. Our number 8, so we're going to take 8 from both sides. So negative 5x is equal to 40. And then divide both sides by negative 5. So x is equal to negative 8. Here again, we want to get the x's together. I want to put the 2x with the 10x. So I'm going to take 2x from both sides. That is gone. So I have 6 is equal to 8x minus 8. Then I'm going to add 8 to both sides. So 14 is equal to 8x. Now dividing by 8 to get rid of the 8. So x is equal to 14 over 8, which cancels to 7 over 4. Alright? Here we have brackets, so we need to expand the brackets using the distributive law. 9 times 4x, that's 36x. 9 times 2, that's 18. 3 times 2x, that's 6x. 3 times negative 5, negative 15. Now we're grouping our like terms. So we're going to first take 18 from both sides. So we have 36x is equal to 6x minus 33. And now we're going to take 6x from both sides. So we have 30x is equal to negative 33. Dividing both sides by 30. So we have x is equal to negative 33 over 30, which is negative 11 over 10. Alright, negative 11 over 10. Here again, we expand our bracket using the distributive law. So negative 3 times 4x, that's negative 12x. Negative 3 times 6, negative 18. Okay, so we're going to subtract 8x so that it comes over here, and we're going to add 18 so that it comes over here, right? So we'll end up with negative 12x minus 8x is equal to 7 plus 18. So this gives negative 20x is equal to 25. So x is 25 over negative 20, or negative 5 over 4. Alright, so again we expand our brackets. Negative 2 times 5x, negative 10x, negative 2 times negative 3, positive 6, 6 times x, 6x, 6 times negative 1, negative 6. So we'll have negative 10x minus 6x, because we subtract 6x from both sides, that will cancel. And we're going to have negative 6 minus 6, this 6 will minus 6 from both sides. So we'll end up with negative 16x is equal to negative 12. So x is negative 12 over negative 16, which is 4 into each of those, 3/4. Alright, 3x minus 2x times 9, that's 18x, negative 2 times 5, negative 10x. Well, all of these have x's, so we can group them. So 3x minus 18x, that's negative 15x minus 10x, negative 25x. And dividing both sides by negative 25, we have x is negative 6 over 25. Alright, remember, if the number is not immediately in front of the bracket, we don't work it with the bracket. So we have 1, negative x times 2 is negative 2x, negative x times negative 8, positive 8x. So that's 1 plus 6x is equal to 40. 6x is equal to 40 minus 1. So 6x is equal to 39. X is 39 over 6. And that goes 6 into 39 goes 6 times and 3 over 6, which is a half. 6 and a half. Alright, now for these, they're fractions, so we're going to work them as fractions. Find the LCM of 8 and 4, which is 8. 8 goes into itself once. 4 goes into itself 8 times, 2 times x. Sorry, 4 goes into 8 2 times, 2 times x, 2x. And 1 goes into 8 8 times, 20 times 8, 160. So we have 5x plus 2x, 7x is equal to 160. X is 160 over 7. 7 into 16, 2 times, remainder 2. 7 into 20, 2 times, remainder 6 over 7. Alright, so now we have some more fractions. So we'll find the LCM of 10 and 5, which is 10. 10 goes into itself once, and we multiply these terms up here by 1. 5 goes into 10 2 times. We bracket these and multiply by 2. So we end up with 3x minus 4 is equal to 8x plus 4. Since they are all over the denominator of 10, we can ignore the denominator and just solve the terms in the numerator. So we're going to have negative 4 minus 4, subtracting from everything by 4 here, is equal to 8x minus 3x. So we're grouping the like terms. Negative 8 is equal to 5x. So x is negative 5, negative 8 over 5. Alright, so here now we have another fraction. We find the else. First, let's expand the brackets, right? We are expanding the brackets. So we have 3x minus 6 over 5, 2x plus 2 over 3, and we have equals 25 over 1. So now we find the LCM of 5 and 3, which is 15. 5 into 15 goes 3 times, and we're multiplying each term by 3. So 3 3 is 9, 3 6 is 18. 3 into 15 goes 5 times. Now remember, this negative sign is going to change this one, right? So 5 2s are 10, negative times that, and negative times that. 3 into 15, 5, 5 2s are also 10, so that's a negative 10. And 1 into 15, 15 times, 25 times 15, 5 5s 25, 5 2s 10, and 2 12, 375. So now we're just going to work the top, and we don't have to include the denominator because they're all over a common denominator. So 9x minus 10x is negative x. Negative 18 minus 10, negative 28. So negative x is equal to 375 plus 28, which gives 8 and 5, 13, 7 and 2, 9, and 1, 10. So x is negative 403. Okay, finally, again, we're going to write back what we have and expand this bracket here. 2y plus 12. Find the LCM of 4 and 9. 9 goes into 36 4 times. We'll multiply each of these by 4. So we'll get 4y minus 12. 4 into 36 9 times. We'll multiply each of these by 9. We'll get 18y plus 108. And 1 into 36, 36 times. 8 times 36, 8 6 is 48. 8 3 is 24, and 4 28. That's 288x. And that's as simple as we have it actually, because we have two variables. Actually, I think this was a y. This should be a y. Right, so it's one variable we're supposed to have. Alright, so now we're going to group the like terms. So we have negative 12 plus 108 is equal to 288y minus 18y minus 4y. So this gives negative 12 plus 108. So that's going to give 96. And 288 minus 18, that's 270 minus 4, 266 y. So we end up with 96 over 266 y. And that's going to give us 48, 133y. So y is 48 over 133. Alright, so the idea is we isolate the like terms, right? Isolate the variable so that we have it by itself, preferably on the left. If it's a case where we have brackets, we need to expand the brackets first and then group our like terms. If it's a case where we have fractions, we have to find the LCM just like we would for regular fractions and still trying to eventually isolate the variable, get it by itself, and then we have solved our equation. Alright, so if you have benefited from this video, just drop a line to say thank you, miss, and share the video so others may benefit as well. And I'll see you in the next video.